Theoretical recap. Documenting network status means capturing a reliable snapshot of what your Linux host exposes and communicates on the network at a given moment. The core mental model is a layered inventory: interfaces, link and IP configuration, listening sockets, services waiting for connections, active connections, established sessions, and the processes that own them. Each open port is an attack surface. Each unexpected connection is a potential indicator of compromise. Key tools you already practiced: IP inspects interfaces, addresses and routes, replacing legacy ifconfig and root. SS lists sockets far faster than netstat, with flags such as T, TCP, U, UDP, L, listening, N, numeric, P, owning process. Netstat remains a fallback on older systems. Pair these with process tools, PS, signals, systemd, so every open port maps to a named service. Common mistakes: running SS or netstat without sufficient privileges, which hides the owning PID/program, forgetting to distinguish listening from established sockets, ignoring both IPv4 and IPv6, and confusing 0.0.0.0.0, all interfaces, publicly reachable, with 127.0.0.1, loopback only, local. Mini example: sudo ss tulpan outputs a listening TCP socket on 0.0.0.0.0:22 owned by process SSHD. Reading this correctly, you conclude that SSH is exposed on every interface, a fact worth documenting and justifying from a security standpoint. Workshop brief. Your objective is to produce a professional-grade network status document for a Linux host, your own machine, a VM, or a container. This document is the kind of baseline a security analyst produces before a pen test or an incident review, so it must be accurate, reproducible, and interpreted, not just a raw command dump. Start by describing the host, hostname, OS/kernel version, and the network interfaces present, name, state, MAC, IPv4/IPv6 addresses, MTU, using the IP tooling. Then establish the routing picture, default gateway and routing table. Next, build a full inventory of listening sockets for both TCP and UDP, including the owning process and PID, and clearly separate services bound to loopback from those exposed on all interfaces. After that, capture the currently established connections and note any remote peers, distinguishing legitimate traffic from anything you cannot immediately explain. For every exposed service you find, cross-reference the owning process with what you learned about processes and systemd. Identify the systemd unit responsible, confirm whether the service is enabled at boot, and briefly assess whether its exposure is justified. This linking of ports to services to units is the heart of the exercise. Finally, synthesize your findings into a short security assessment. Which ports represent the largest attack surface, which services should arguably be restricted to loopback or firewalled, and what you would recommend hardening first. Deliver a single structured report, Markdown or PDF, that includes the exact commands you ran, their sanitized output, your interpretation of each section, and your prioritized recommendations. A reviewer should be able to rerun your commands and reach the same conclusions.